look at an example of what I mean. So this is an example where up top we have a polynomial, and in the bottom we have a monomial. Again, monomial means there's one term. So what we can kind of think about is going on here is we can think about this as 6x to the fifth plus 9x to the fourth minus 3x. We can think about that as being in parentheses, and then it's multiplication by 1 over 3x squared. So that really means the same thing, that to divide by 3x squared means the same thing as to multiply by 1 over 3x squared. What happens then when I distribute this is as I distribute to the first term, it becomes 6x to the fifth over 3x squared. For the second term, it's 9x to the fourth over 3x squared. And for this last one, we're going to end up with a 3x in the top and a 3x squared in the bottom. So if you look back to the original problem, we really could have jumped right to this step without that intermediate step. I want to point out why we can. So this is why we can distribute when it comes to division, is because we can think about division as multiplication by the reciprocal. Now with each of these terms, we can now simplify them. With that first term, 6 divided by 3 is 2. And if I have 5x's on the top and 2 on the bottom, we subtract. 5 minus 2 is 3. So 2 of them divided out. For the second term, 9 divided by 3 is 3. X to the fourth over x squared leaves me an x squared. Now we got to be careful. Now the subtraction sign carries down. We can think about it again as a negative sign if we prefer. The 3's divide out. Remember, dividing out means they're equal to 1, that 3 over 3 is 1. So similarly with our x over x squared, we want to think about that as x over x times x. The x's will divide out, leaving an x in the bottom. But by dividing out, we mean we're left with a 1, because anything over itself is 1. So that simplifies down to 1 over x in that case. And there's our answer to the division problem.